Imagine a chemical that can spontaneously explode. Manganese heptoxide was first synthesized in the 1860s, and I think it has some interesting properties. It is made by mixing two relatively common chemicals, and the first one is concentrated sulfuric acid. I'll add about 2 milliliters of the sulfuric acid using a pipette, and then I'll sprinkle on a bit of the potassium permanganate. When they're combined, a green oily liquid forms, and the reaction that's happening is the sulfuric acid is reacting with the potassium permanganate to form permanganic acid. This acid is dehydrated by the sulfuric acid, with the water being pulled out. This new molecule is the result of two permanganic acids, and it is really unstable. This is a very strong oxidizer, and it will do anything it can to decompose. This can happen by reacting with something, or just spontaneously. Here's another sample of manganese heptoxide, and it's set off with just a hot piece of metal. The green oil you see on top was the manganese heptoxide, and almost instantly it all reacted. However, you don't have to worry too much about it spontaneously decomposing if you minimize the amount of potassium permanganate or if the temperature is below 55°C. With all of that said, it is still very dangerous and it has to be treated with respect. I made a new sample, and for the first experiment, I'll just drop a cotton ball on it. The reaction was pretty quick, and it also generated a lot of heat, so immediately it bursts into flames. Most of the heptoxide either reacted or decomposed instantly, so the reaction didn't last for very long. I added some water, which destroyed any remaining heptoxide and converted it back to the purple permanganic acid. The brown liquid that you see here is the manganese dioxide. So for the next test, let's see what it does to a cheese cracker. Interestingly, it didn't react as violently as before, and only a few sparks were generated. I also tried it with some sugar. Almost instantly, it is converted into carbon and released a lot more smoke, which was the manganese dioxide. For the next test, I was curious if anything would change if I added a lot more permanganate and there was a lot more heptoxide floating on top. I thought that this would make the reaction quicker and more violent, so I dropped another cotton ball. However, I noticed that the reaction was more delayed, which was quite odd. I have noticed that the decomposition reaction happens in two stages, where the first one is directly between the heptoxide and the cotton. The amount of heat generated was then able to decompose the rest of the heptoxide, which split apart into manganese dioxide, like I mentioned before, as well as a bunch of oxygen and ozone gas. These two gases are then able to immediately react with the burning cotton, which causes it to erupt into flames. Mixing an oxidizer and a fuel is the basic recipe for making an explosive, which should be handled very, very carefully. Additionally, unlike other explosives, the manganese heptoxide can be extremely unstable and unpredictable. At this point, I've only been using solids, but I wanted to try it with some liquids. Basically, any flammable liquid should work, and I tried it with some acetone first. For the liquids, I used the more concentrated version by using more permanganate. The reaction was nearly instant because the liquid has a higher surface area. It was only visible for a few frames on my camera. For the next run, I tried it with a drop of methanol. Like before, the reaction was also super fast, and I thought it looked pretty cool when I slowed it down. It formed a nice mushroom cloud. I also wanted to try it using a test tube. It did look cool and resembled a volcano. That's it for this video. If you enjoyed this video as much as I enjoyed creating this video, then please leave a like or subscribe. Thanks for watching.